Voltage is defined as the difference in electrical potential from one point to another. But seriously, what is voltage? There are so many formulas to explain voltage, yet formulas don't explain formulas. People explain formulas. So now let's go and take a look at what voltage has to offer. Okay, so we are outside and I have a bottle. I have two bottles and we are going to perform experiments to know voltage a little bit better. So right here we have a bottle filled to the brim, and in fact we punch a hole to let some water through. Now, how is this similar to a voltage and in our case a battery? Now consider this. There is a small hole at the bottom of this bottle and it's leaking out water. But it's not a lot of water because the hole is small. Now consider what happens when I try to squeeze on the bottle. The water becomes stronger. Consider a smaller bottle. Now we know that because the bottle is smaller, it has lower amount of pressure acting on it. Does that mean a lesser amount of water is going to flow out of this bottle? Well, let's see. Now, as you can see, and you might have already predicted, the bottle empties itself very quickly. Therefore, the current is actually humongous, even though the voltage in our case is very low. I wasn't even pressing on the bottle, and the bottle is small enough that the water pressure acting on the water is relatively small. So what's the difference here? The difference is the size of the hole. Now, the bigger the hole is, the more water can flow out of it quickly. From here, we can conclude that not only does pressing on the bottle increase the rate of flow, the size of the hole itself also increases the rate of flow. Here, the area of opening is represented as 1/r because the resistance decreases when the area increases, and vice versa. Now we can put everything we have just learned together and derive Ohm's law for ourselves. Alright, let's look at the biggest lie of the century, a 1.5 volt battery. Why is this a lie? Because it's never 1.5 volt. To understand why, we will use balloons as our analogy. When you want to tap onto the rich juices of electrical power, you have to unleash the battery. And that's like letting go of a balloon. It shrinks in size. You can see that the balloon loses its air faster initially and it gets lower over time. It's just like a curve. This means that when the bulbs in the circuit gets dimmer, not only is the current reduced, the voltage is reduced too. What will happen if I reverse this process? Instead of letting the voltage level run its course, I try instead to increase the voltage using force. Watch me as I fail to blow the balloon into size due to insufficient pressure. Now watch me try again as I enlarge the balloon by increasing my pressure over time. Now we can deduce a relationship between pressure and capacity, where pressure is represented by V and capacity is represented by Q. Q equals to kV. There we have it, another concept of electronics understood through everyday objects.